So where I was, yes, I was deriving the expression for the sharpness of resonance. That is actually the reciprocal of the delta value, where the E total, the total energy, will be half of the maximum energy. Okay, so we were deriving this. So there were some problem in the derivation, that if we have written E total is equal to 4E max. Okay, so it will not be 4E max only, it will be 4B square E max. Okay, B square term we forget. So this we also here. So finally what we will get, this 4B square. Okay, omega square del dash square is equal to 4B square. So what will be del dash? You can write it as a 2B by omega. So what will be the sharpness of resistance? Sharpness of resistance will be omega by 2, because this sharpness of resistance will be the reciprocal of the delta. So this will be omega by 2p. Omega is the natural frequency of the oscillator, B is the damping constant. Okay, so we have already discussed this graph in between the total energy and delta. So in this graph you can see for low damping, this sharpness, this total energy is maximum, for the larger damping it's minimum. So this kind of nature we have already discussed. Now I would like to go to the next topic, the quality factor. What is quality factor? Okay, let's take a new page. Quality factor. Okay, so quality factor of a forced oscillator, we will derive this. Okay, so now if you apply like the forced an external periodic force, if you apply on any oscillating system external periodic force, let's say this F cos omega dash t you are applying. Okay, and you are applying this force for a dt time. Okay, then in this dt time, let's say that oscillating system is displaced by dy distance, then what will be the work done? Means work supplied by the external force. What will be the work? dw will be F cos omega dash t into dy. Okay, and if you calculate the power will be nothing but dw by dt. Okay, that will give you F cos omega dash t dy by into dy by dt. Okay, and dy by dt, you know that this will be a omega dash minus a omega dash sine omega t minus alpha, because y is a sine omega a cos omega dash t minus alpha, you know, for the forced oscillator. So put this here, so the power will become F cos omega dash t minus into a omega dash sine omega dash t minus alpha. Okay, so now you just expand this, then what you will get? A omega dash, so what we will get? Sine omega dash t cos alpha minus sine alpha cos omega dash t. Okay, so now we can write it as a omega dash f cos omega dash t sine omega dash t cos alpha minus cos omega dash t square sine alpha. Okay, so Now calculate the average of power, means average power. So what will be the average power? Cos omega dash t sin omega dash t cos alpha minus cos square omega dash t sin alpha. Okay, so this average, if you calculate, this is your assignment, you show me in the next class how it will become 0, the average of this cos omega dash t sin omega dash t. Okay, so and this average will be half. Okay, so what you will get, P average is equal to minus a omega dash f half sin alpha, because this will become 0. Okay, so P average you will get this. This how you will calculate this average omega dash e. I will just give you hint. Just take the integral from 0 to infinite omega dash dt. Okay, and similarly for this, for getting the average of this. Okay, so similar things you will do for this. So now we know what is a. A is nothing but small f divided by root over omega square minus omega dash square whole square plus 4b square omega dash square. Okay, and sin alpha, we know the tan alpha. What is tan alpha? Tan alpha we have derived above. Let me check. This tan alpha. Tan alpha is 2b omega dash upon omega square minus omega dash square. Okay, so from here you can calculate the sin alpha. What will be the sin alpha? Okay, so tan alpha, let's plot this diagram. This is alpha. This will be 2b omega dash, and this will be omega square minus omega dash square. Okay, so what will be this? This will be 4b square omega dash square plus omega square minus omega dash square का whole square. Okay, so sin alpha will be nothing but 2b omega dash divided by root over omega square minus omega dash square का whole square plus 4b square omega dash square. Okay, so what we will get, P average is equal to minus half this minus is still going. This integral will be nothing but 0 to t 1 by t. Okay, so minus half this minus y, this is coming, there should not be minus. Okay, this minus minus will get plus now. This will become plus. Yes. So this is plus. So what is A? A we put F omega dash capital F divided by root over omega square minus omega dash square का whole square plus 4b square omega dash square, okay, into sin of 2b omega dash divided by this will be also root over omega square minus omega dash square का whole square plus 4b square omega dash square. Yes. So this f is nothing but m into small f. Okay. So we can try to try this. So P average you can write 1 by 2 but f square omega dash b divided by omega square minus omega dash square whole square plus 4b square omega dash square. Okay, so this is the expression for P average. Now the omega dash value where P average will be maximum, that value you can calculate by just dp by d omega dash. It should be 0, and also d2PAV at that value of omega dash this second integral should be less than or equal to 0. Okay, so for this we first differentiate with respect to omega dash this. So what we will get minus f square omega dash b divided by omega square minus omega dash square का whole square plus 4b square omega square. Okay, so this will be 0, and this d2 3 omega dash square f square omega dash b omega square minus omega dash square का whole square plus 4b square omega square is less than. So when this will be equal to 0 or when this will be less than or equal to 0, in the condition where omega will be omega dash, means it is equal to omega dash, in this situation only this will become 0. Okay, so what will be the maximum value of power? The maximum power, put omega is equal to omega dash, so we'll get f square omega square b divided by this will become 0, this will be 4b square omega square. So this will cut, so what will be P max? Oh, where is M? I have not written M, I think. Yes, this is M now. So what we will get then? It will be mf square by 4b. Is it fine? Yes. If we put it in terms f is equal to f by m, then what we will get? P max is equal to f square by 4mb. Okay, this will be P max. So the P average can also be written in terms of P max. Okay, so P average divided by P max will be what? P average is this f square m. So this f square omega dash divided by omega square minus omega dash square whole square plus 4b square omega dash square omega dash square divided by f square by 4mb. Okay, so f square will be cut. Then what we will get? Whole b omega to omega dash upon omega square minus omega dash square by whole square plus 4b omega dash square. So p average is equal to p average by p max is equal to this. Okay, so it's not matching. 4mb. Should be total basis. So this will be b square. Omega into omega dash. Okay, this is not omega, this is omega dash. So this will be omega dash square. Okay, this is not omega. So 4p square. So p average will be p max 4b square omega dash square divided by omega square minus omega dash square plus 4b square omega dash square. Okay, so here we have done some mistake, that's why we were getting omega into omega dash. Actually this is here you can see this is omega dash. Okay, p average it's actually omega dash. From here if you see this is omega dash, so this will be omega dash square. Okay, so now if you plot this p average with respect to the omega dash, p average with respect to omega dash, then what you will get? You will get this kind of plot. Okay, this kind of. Okay. So here this will be p max, and here omega dash will be equal to omega. Okay, here, and this is the point, means the value of omega dash where the power, the average power will be half of the p max. So this will called half power point. Okay, half power points. So now let us calculate this half power points, where on which value of omega dash this half power points we will get. So for that what we will do, we will put p average is equal to P max by 2. Okay, so put it here. So what you will get, so put it here. So we will get half is equal to 4b square omega dash square divided by omega square minus omega dash square whole square plus 4b square omega dash square. Okay, so now solve it. I am doing this derivation, you have to also do in your exam. Okay, if question will be asked, these kind of derivation are important to understand, because without understanding this you can't understand the physics. Mathematics complements the physics, so you should understand everything. So omega square minus omega dash square, this will be plus minus 2b omega dash. So one equation you will get minus 2b omega dash minus omega dash square is equal to 0, and the another equation you will get omega square 2b omega dash minus omega dash square is equal to 0. So if you want to see what will be the omega dash, so you can also write it like this: plus 2b omega dash minus omega square is equal to 0, and omega dash minus 2b omega dash minus omega square is equal to 0. So one value of omega dash will be from the Sridharacharya rule. What will be this? That minus b plus under root b square minus 4ac. So 4ac, this will be b square plus omega square. Okay, and the another will be from here with that b plus under root b square plus omega square. Okay, so if you calculate, this is the this let's say this is the omega 1, let's say this is the omega 2. Okay, this is the omega 1 omega 2 we have derived here. Okay, omega 1 omega 2. So delta omega means the difference between the two half power points. Omega 1 minus or omega 2 minus omega 1 will be 2b. Okay, so what will be the quality factor? Quality factor is defined as a ratio of frequency divided by the bandwidth. This is nothing but actually the bandwidth. Okay, bandwidth means the difference between the two half power points. Okay, that is the bandwidth. So what is the bandwidth we have calculated is 2 by it is 2b. So this is nothing but the sharpness of resonance. We have in the previous topic we have discussed the sharpness of resonance, that was omega by 2p. That is the same as the quality factor. Means the sharpness of resonance can be also determined or measured. Resonance can be measured in terms of quality factor. Okay, for what? For the forced oscillator. Okay, so that's all. The derivation for the quality factor. What we have done, first we have calculated the power, then average power, then maximum power, where the value of omega dash where maximum power will occur. Then what will be the maximum power, then the relation between the average and the maximum power, and from that we have calculated the bandwidth. What will be the bandwidth of the spectrum, this spectrum in between the p average and the omega dash. So from that bandwidth we can calculate the quality factor. Okay, that is nothing but the sharpness of resonance. Okay, now we have seen the electrical analogy of the simple harmonic motion or the free vibration, and also for the damped vibration. Now we will see the electrical analogy for the forced vibration. Okay, means the forced vibration in, and that electrical analogy will be LCR circuit with an external AC source, okay, post vibration. So this is the LCR circuit we have already seen. L, this will be R, and there will be an external EMF will be applied from an AC source, an external AC source. This is the capacitor, okay. This is nothing but the EMF is equal to E naught cos omega dash t, okay. And this battery is connected with the this capacitor is connected with the battery, and there is another key that this is K1, this is K2. So initially when K1 is closed and K2 is open, this C and the battery, this capacitor will start charging from the battery, means it will start accumulating the charge carriers, and then as soon as this capacitor will be fully charged, then this K1 will immediately become open, and the K2 will become closed, okay. So this LCR circuit will make a closed circuit. Then what will happen? Then in that case, let's say at time t the charge through the in the capacitor is Q, then the voltage across the capacitor will be Q by C, and the voltage across this inductor L, and this R. So through inductor it will be minus L di by dt, or you can write it as a d2q by dt square, okay. Similarly, the voltage across the resistance that will be minus IR, that is nothing but R dq by dt, and the external AC source that is applied to compensate the loss because of the resistance, okay. This AC source is actually applied to compensate the loss, okay, so that the circuit, the closed circuit, the charge in this closed circuit will oscillate indefinitely, okay. That will oscillate with the frequency of the external AC source, okay. So what is the external EMF? E is equal to, this is E naught cos omega dash t. So the Q by C will be nothing but E naught cos omega dash t minus L d2q by dt square minus R dq by dt, okay, from the Kirchhoff's law, okay. The total voltage, this will be the total voltage. So you can write it like this, plus R dq by dt plus Q by C is equal to E naught cos omega dash t, okay. So now you can also write it like this, dt square plus R by L dq by dt plus Q by LC E naught by L cos omega dash t, okay. So now you can write it d2q by dt square, the R by L as a 2b dash, b is the damping constant, dq by dt plus omega square, where omega square is 1 by LC and R by L is 2b dash, okay. Is E naught by L, E naught by L you can write it as a f dash cos omega dash t, okay. So this is nothing but equivalent to the equation of a forced vibration, differential equation of a forced vibrator for a mechanical oscillator. What is the differential equation for forced vibrator? It is this, dy by dt plus omega square y is equal to f cos omega dash t. So this equation is analogous to this equation, okay. Means LCR circuit with an external AC source will behave like a forced vibrator, okay. force by beta. And the solution of this differential equation you can derive in the same way as we have done for a mechanical oscillator. Okay, so that's all. These are now I have covered all the topics in the oscillation chapter. So now if you have any problem, any difficulty in understanding, you can come to me in my office, because now we don't have any class, but in my office you can come. I will explain everything. Okay, so don't hesitate. And the assignments you have to submit in my office. Okay, so let us adjourn this class. See you again.